Hello, hello, and welcome to this read through of PostgreSQL manual. So we will have examples later on. Now as I said in my last video, we will cover section 9.22, that is window functions, and 9.23 merge support functions. However, we will not have example in this video unless we finish subquery expressions. So the example of 9.22, 23, and 24 will be given together. The reason is that window functions involve a lot of subquery expression. The examples are well suited for a combination of both. And that is why we will have the example once we finish subquery expressions. So let's get started with window functions. They are mighty useful. Window functions provide the ability to perform calculations across sets of rows that are related to the current query row. See section 3.5 for an introduction to this feature and section 4.2.8 for syntax details. The built-in window functions are listed in table 9.67. Note that these functions must be invoked using window function syntax. That is, an over clause is required. In addition to these functions, any built-in or user-defined ordinary aggregate, that is, not ordered set or hypothetical or set aggregates, can be used as a window function. See section 9.21 for a list of the built-in aggregates, which we have already covered. Aggregate functions act as window functions only when an over clause follows the call. So we have select count star. Okay, now we can call select count over. So similarly, we can do that, select average over, and so on. Otherwise, they act as plain aggregates and return a single row for the entire set. So now we will go through general purpose window functions. First one is row number, returns a begin. Returns the number of current row within its partition counting from 1. Then we have rank, which also returns begin. Returns the rank of the current row with gaps, that is row number of the first row in its peer group. Then we have dense rank, also returns begin. Returns the rank of the current row without gaps. This function effectively counts peer groups. Then we have percent rank, which is double precision. Returns the relative rank of the current row, that is rank minus 1 divided by total partition rows minus 1. The value thus ranges from 0 to 1 enclosure. Then we have cumulative distribution, which also returns double precision. Returns the cumulative distribution, that is number of partition rows preceding or peers with current row divided by total partition rows. The value thus ranges from 1 upon n to 1. Then we have entile, num buckets, integer is the argument, returns an integer. It returns an integer ranging from 1 to the argument value, dividing the partition as equally possible. Then we have lat, which takes any computable value, and optional arguments are an integer offset and any computable default, and returns any computable. Returns value evaluated at the row, that is offset rows, before the current row within the partition. If there is no such row, instead returns default, which must be of a type compatible with the value. Both offset and default are evaluated with respect to the current row. If omitted, offset defaults to 1 and defaults to null. So the variable default will be by default null. Then we have lead, similar signature as lag. Returns value evaluated at the row, that is offset rows after the current row within the partition. If there is no such row, instead returns default, which must be of a type compatible with value, and the rest of the description is similar as lag. Then we have first value, takes an argument value, an element, returns an element. Returns value evaluated at the row, that is the first row of the window frame. Then we have last value, similar stuff, but it works with the last row of the window frame. Then we have nth value, takes any element value and an integer n, returns an element. Returns value evaluated at the row, that is the nth row of the window frame counting from 1. Returns null if there is no such row. All of the functions listed in table 9.67 depend on the sort ordering specified by the order key clause of the associated window definition. Rows that are not distinct when considering only the order by columns are said to be peers. The four ranking functions, including cumulative distribution, are defined so that they give the same answer for all rows of a peer group. Note that first value, last value, and nth value consider only the rows within the window frame, which by default contains the rows from the start of the partition to the last peer of the current row. This is likely to give unhelpful results for last value and sometimes also nth value. You can redefine the frame by adding a suitable frame specification range, rows, or groups to the overclass. See section 4.2.8 for more information about frame specifications. When an aggregate function is used as a window function, it aggregates over the rows within the current rows window frame. An aggregate used with order by and the default window frame definition produces a running sum type of behavior, which may or may not be what is wanted. To obtain aggregation over the whole partition, omit order by or use rows between unbounded preceding and unbounded following. Other frame specification can be used to obtain other effects. We have a note. The SQL standard defines a respect nulls or ignore nulls option for lead, lag, first value, last value, and nth value. This is not implemented in PostgreSQL. The behavior is always the same as the standard's default, namely respect nulls. Likewise, the standard from first or from last option for nth value is not implemented. Only the default from first behavior is supported. We can achieve the result of from last by reversing the order by ordering. Now we have merge support function, which has only one function. So PostgreSQL includes one merge support function that may be used in the returning list of a merge command to identify the action taken for each row. So it talks about this table, merge action returns text. Because the merge action command executed for the current row, this will be insert update of the week. So an example is given, merge into products P using stock S on P.product ID is equal to S.product ID. So both stock and products tables have a product ID column. When matched and S.quantity greater than 0, then update set in stock is equal to true. Quantity is equal to S.quantity. When matched, then update set in stock is equal to false. Quantity is equal to 0. When not matched, then insert product ID, comma, and stock, comma, quantity values S.product ID, comma, true, comma, S.quantity. So essentially what it is doing is that it is comparing the product ID, and when it matches and stock quantity is greater than 0, then stock is set to true, quantity is set to the quantity from stock. Otherwise, what it does is stock is equal to false and quantity is equal to 0. And when it doesn't match, it inserts the product ID in stock set to true and quantity set to stock quantity in the product table, and returns merge action e dot star. So you see, there are several things which can happen. An update can happen here, two updates and one insert. So merge action will be either update or insert, and the p dot star for those actions is also shown here. Note that this function can only be used in the returning list of a merge command. It is another to use it in any other part of the query. Next is subquery, but we will hold on to it. Let's see how big it is. So not too big, okay? Not too big. So we can finish this tomorrow, or should we continue? We will do this tomorrow. So we will finish the subqueries tomorrow, and we will also look at the example. Like all the examples, I will show only part of it, and rest will be there as a gist in GitHub. So I will end this video here. It is relatively a shorter video. So tomorrow we will study subquery expressions, and I hope that you have found this video useful and informative. These window functions are quite useful, as well as remember that the aggregate functions with an over clause can be used as window function. So we'll cover all that. And with this, I'll end this video here and we'll meet tomorrow with another video on PostgreSQL. Till then, stay curious, keep learning, and most importantly, enjoy.